Hello everyone, welcome to this webinar titled How to Choose the Right Camera for Your Product, organized by Econ Systems and Silicon Highway, who are our distribution partner for UK and Europe. Cameras are an indispensable part of every vision product, especially when they make our lives easier. This autonomous driving system helps travelers, especially ones who have difficulty walking, navigate through the airport comfortably without any assistance. This system is powered by Econ's stereo camera for depth mapping on NVIDIA Jetson TX2 platform. For your takeaways, in this webinar, we will discuss about various factors involved in choosing the right camera and interface for your application. We will look into few case studies on how Econ have supported our customers with integrating the right cameras in their product. Finally, we will see how Econ can accelerate your development time with our off-the-shelf camera solutions. After this, we will have a Q&A session to address any queries you may have. For this webinar today, we have three presenters. Mr. Dilip Kumar, Project Lead, Camera Products and Research in Econ Systems. Mr. Graham Brown, Design and Marketing Director from Silicon Highway. And myself, Seshagopalan, Business Development Manager heading Europe and UK in Econ Systems. Myself and Graham would like to give you all a quick introduction about Econ Systems and Silicon Highway, followed by which Dilip will take you through the webinar topic. Making missions see since 2003, Econ Systems designs, develops and manufactures OEM cameras. With world-class expertise in ISP, our engineers ensure that all our cameras are fine-tuned for optimum image quality. We have a wide range of off-the-shelf solutions, both MIPI and USB, and our portfolio extends in supporting GMSL interfaces as well. Being pioneers in the field, we also support any customization requests to make your concept a reality. For almost 2 decades, catering to the European market means living up to the highest of quality standards, and ISO 9001:2015 certification backs up our statement. The typical mean time between failures of our cameras is 8 years, and we offer 3 years of warranty for all our products. One of our greatest strengths is our partnership with leading sensor manufacturers like Sony, OmniVision and ON Semiconductor. We get first-hand information from them about end-of-life announcement. With this well ahead of time knowledge, we help our customers in planning their production volumes by leveraging the last buy option, thus supporting the customers with 5 to 10 years of product lifetime. We also ensure that they have a smooth transition to replacement sensors. Econ Systems have been instrumental in deploying more than 300 plus customer products in the market, and these customers give us year-on-year business with volumes more than 500 units becoming our design win customers. We cater to a wide range of markets including but not limited to industrial, retail, medical, smart city, agriculture, sports and entertainment, biometric access control. So, how are we able to help our customers from all these sectors with their different volume requirements? We work with our strengths, our partners. Econ have always acted as a bridge between the high volume demanding sensor vendors and customer with low volume. We fully understand the many challenges a customer faces in bringing their concept to the market as a fully evolved product, and we ensure to stand by them in every step of the way. Our strong partnership with companies like Socialist, ON Semiconductor help us fine-tune ISP to provide optimum image quality. Econ Systems are the world's first company to launch USB 3.0 UVC compliant cameras thanks to our great partnership with Cypress. We are NVIDIA's elite partner, which means we have access to their inbuilt ISPs, allowing us to not only create a great portfolio of products but also custom develop a camera based on our customers' requirement. Should you choose to go with Connectech and Evermedia for your career board needs for faster deployment of your products, we have got you covered with our partnership with them as well. Silicon Highway is our distribution partner for Europe and UK. With their elite partnership status as well with NVIDIA, they are our customers' one-stop shop to purchase our cameras and a suitable platform for faster evaluation and time to market. Requesting Mr. Graham Brown to take over and introduce Silicon Highway.
Thanks, Sasha, and thanks to everybody who's joined us on our webinar today. My name's Graham Brown, and I'm the Design and Marketing Director for Silicon Highway. And for the next 5 minutes, I'm going to give you a quick insight into the Silicon Highway and also what we offer to the market. Silicon Highway is a European-focused embedded distribution company. And our history of providing enabling technologies to the likes of electronic designers, manufacturers, and also educators within Europe started in 1997, covering in design in, from supply support, marketing promotions, and also technical sales. We currently have 2 subsidiaries, one located in Ireland and the other one located in the UK, and the former supporting product distribution across Europe. We support all major embedded vertical markets, including automotive, consumer, industrial, as well as all of the new emerging AI markets, for example, robotics, medical, IVA, agro, and so on. Silicon Highway's relationship with NVIDIA spans over 20 years of providing NVIDIA embedded solutions and also discrete graphics cards into the European marketplace, which has helped us gain elite partner status with NVIDIA. We currently have over 8,000 Jetson European customers and also over 800 mature projects live in the market with NVIDIA Jetson at the edge. Silicon Highway was the first NVIDIA embedded European embedded distributor to market. And we're also dedicated and focused only on NVIDIA Jetson-based technology and associated products. We only supply products that have been vetted technically and only complement each other rather than compete. Through our online platform, siliconhighwaydirect.com, we offer a full range of NVIDIA Jetson-based modules and development kits, as well as a full selective range of eco-partner boards, for example Connectech and AVMedia, as well as custom coolers. We offer a full selective range of embedded cameras. We have storage from Samsung. And we've also put together educational kits based on the NVIDIA JetBot and also the NVIDIA DLI, which is the Deep Learning Institute courses. Silicon Highway's embedded camera specialists are Econ systems. And we offer a full range of high quality cameras, anything that would deal with the NVIDIA Jetson Nano Development Kit, upscaling up to the AGX Xavier. And hopefully with the rest of this webinar, we'll gain some valuable insight in terms of what factors to consider and also the technical differences in when choosing a camera that's correct for our project.
Thanks, Graham. Now I request Dilip to take us all through the thought-provoking session.
Thanks for the intro, Sesha and Graham. Hi, this is Dilip, and it is a pleasure to be here with you all today. All right, now let's get down to business. I'm going to take you all through the factors to keep in mind while choosing the camera, what are the different interfaces available, and how you can choose the camera and build vision solutions for different applications. But before we begin, I want to address a common myth prevailing among new camera users, that is, high resolution always equals to great image quality. Actually, no, that is not always true. The performance of a camera is decided by various factors rather than just the resolution it supports. So what are these factors? Let's check them out. Remember to keep the target scene in mind while choosing these factors. The first thing you have to consider is the lighting condition of the scene. Is the scene going to be well lit? Is it an outdoor or an indoor scene? What type of lighting is present? Is it an artificial light which remains static in terms of brightness and color temperature? Or is it natural light which varies in brightness as well as color temperature depending upon the time of the day? Based on the answers to these questions, you might need a camera which supports certain features. For example, in an outdoor environment such as a traffic intersection, the lighting condition can vary throughout the day. Also, the same scene can contain brightly lit objects such as vehicle headlights, glare from other street lights, as well as alleys and dark corners. This would make a camera with HDR capability ideal for this scenario. The second thing to keep in mind is the type of target the camera is going to capture. Is the target in your scene going to be stationary or moving? If it is a moving target, how fast will it be moving? This can be crucial in choosing the type of sensor readout mode for your application. When I talk about sensor readouts, there are two types of sensors, namely rolling shutter and global shutter. They both have their own advantages. For example, let's consider a target which is stationary or moves at a speed less than 1 meters per second. This type of scene can be captured without any motion blur when the exposure time is set to a very small value. A photography enthusiast would use a shutter speed of roughly 1 by 1000th to 1 by 250th of a second for this scenario. If the target is moving at speeds greater than 1 meters per second, it is best to go with a global shutter camera, which allows you to capture the entirety of the scene in one single shot. The next factor to keep in mind is the level of detail required on the captured image. The questions you have to be asking now is, are you capturing a scene which requires a lot of minute details to be visible? For example, a document scanner which reproduces a document digitally requires a high level of pixels per inch to maintain good level of readability. Ideally, an 8 megapixel or higher resolution camera is used for such scenarios. But in the case of a surveillance camera, which performs intelligent video analytics such as loitering detection, a resolution as low as 1 megapixel would be sufficient to identify if there is a person in the scene or not. Based on the level of detail and frame rate required for capturing the scene, the interface to connect the camera to a host processor such as the NVIDIA Jetson system can also be chosen. We will cover this in detail in one of the forthcoming slides. Once you have decided about the factors discussed so far, it becomes easier to decide the number of cameras required to capture a particular scene. Some of the questions you should be asking yourself at this stage are, how big is the area I wish to capture? Can I capture the entire scene using just a single camera? What would be the field of view requirements in that case? Depending on the area to be captured, we recommend using a single or multi-camera setup. One of the advantages of using a multi-camera setup is that it allows you to capture a large area while maintaining good level of detail, whereas this level of detail would be lost if a single camera is used for such cases. A typical example of such a scenario is automated sports broadcasting. A multi-camera setup can be used to cover the wide sports field from a single vantage point. The frames from these multiple cameras can be stitched together to create an ultra-high resolution image feed. This camera feed can be passed into an AI box which performs various video analytics such as player tracking or ball tracking to crop the scene and stream them over a network as separate streams. Finally, optics play a key role in bringing together all the factors which I just mentioned. The questions to keep in mind during this stage are, what is the distance of the target object from the camera? Should the camera be able to focus on the object automatically? What is the size of the image sensor chosen for this application? And do I need a lens which works great for low light scenarios? This is crucial to select the lens with the right aperture and focal length. For example, cameras used for NDT applications such as visual quality inspection requires only the parts being inspected to be sharply in focus. The background information is not important in this case. Also, the lighting for such a scene is highly controlled to minimize errors for the computer vision algorithm performing the automated visual inspection. This is why you got to begin with the end in mind. The significance of each factor differs from application to application. So make sure you give these factors a lot of thought while choosing the camera for your needs. I would like to talk about a factor which is not discussed a lot. I'm sure you must have wondered at least once how the iPhone can capture such stunning pictures with just a 12 megapixel camera. Of course, there are a lot of other smartphones which support all the way up to 100 megapixels, right? The secret obviously lies on the capability of the ISP. So, what is an ISP? Let's find out. The ISP, otherwise called an image signal processor, plays an important role in converting the raw data from the image sensor into an actual usable image. The image on the left here shows how the raw data from the sensor looks like, and the one on the right shows the output from the ISP after it has processed the raw data. As you can notice, the one on the right is more relatable to what a human eye can see. Some of the functions that are performed by an ISP are black level calibration, white balance correction, Bayer demosaicing, auto controls of the exposure and focus, image enhancements such as sharpness, denoising, etc. Also, some ISPs can even perform color space conversions from RGB to YUV. All this processing is done in real time, so the end user does not even know that all this processing is happening in the background. The ISP, of course, is not required in the case of a monochrome camera, but for a color camera, it is a necessity. I hope that information was useful in understanding what an ISP is and what it does. There are two ways to use an ISP in the camera. One is by using a dedicated ISP chip, and the other is by utilizing the ISP present in the host processor. I'm going to talk about some of the points to keep in mind while using a dedicated hardware ISP versus using an ISP in the host processor. Using a dedicated ISP almost always gives you a lot of flexibility in terms of fine tuning. The tuning may be in terms of frame rate, image quality, resolution, and so on. However, when using the integrated ISP in the host processor, the options could be limited. For example, the ISP in the Jetson processor series do not have support for fisheye lens distortion correction. A fisheye lens creates a type of distortion called as barrel distortion. This makes straight lines in the scene to appear as curved ones. This could be a problem if wide field of view is required for your application. Also, the usage of a dedicated ISP does not impose any additional overhead on the CPU because all the ISP functions are performed externally. But in the case of a processor with an inbuilt ISP, there could be some CPU load because some of the functions of the ISP may be offloaded to the sections such as the GPU and other components. An external ISP can be connected to a host processor using various interfaces such as MIPI, USB, or serializer deserializer input. Cameras using these interfaces can support an API called as V4L2, also called as Video for Linux 2, is part of the Linux OS and has been a standard for embedded vision cameras since 2002. There is a huge community of developers who have been using V4L2 to talk to cameras since then. Even the most popular computer vision library called OpenCV supports it. However, in the case of the ISP present in the processor, there could be custom APIs required to access the camera output data. For example, the NVIDIA ISPs use an API called as libRgus through which the user can grab frames from the camera. Although libRgus is new, adoption of libRgus based cameras have been growing with support from NVIDIA. Not everybody can interface a camera to the NVIDIA Jetson ISP. Only few elite camera partners have access to the NVIDIA ISP to fine-tune the camera sensor settings to get the best image quality. Because of the closed nature of the ISPs, it is best to work with the partner who has access to the NVIDIA ISP and has experience with it. Alright, now that you know about the importance of the ISP in a camera, let's look at the different interfaces available to connect the camera to a host computer or system. There are many interfaces to connect the cameras to the host processor, but I want to bring the most commonly used ones to your attention. They are the MIPI interface, the USB interface, the serializer deserializer interface, and the gigabit Ethernet interface. The first factor to consider while choosing the interface is the bandwidth that you need for your application. To find out that information, you should have a good understanding by now about the resolution and the frame rate required from the camera. To give you an example, a full HD or 2 megapixel stream of uncompressed UI/VY data at 60 frames per second requires a bandwidth of roughly 2.4 gigabits per second, whereas a 4K or 8 megapixel stream at 30 frames per second requires double that. There is a formula to calculate the bandwidth requirement of the camera. You can use that to find out how much bandwidth is required. The second most important factor for choosing the interface is the cable length between the camera and the host processor. MIPI is the commonly used interface for high bandwidth requirements as it supports a bandwidth of 10 Gbps when used in a 4-lane configuration. The GMSL interface supports the second highest bandwidth of 6 Gbps. The USB interface is available in various configurations, but the most popular ones are USB 3.0 and USB 2.0. The USB 3.0 interface supports a bandwidth of 5 Gbps in theory, but in real life it is much lower than that. Also, the USB 2.0 interface can support only 480 Mbps in theory. Similar to 3.0, the real life speeds of USB 2.0 is also much lower. When it comes to length of the cable, the Gigabit Ethernet interface tops the list with support for up to 100 meters, but it falls short in bandwidth support of just 1 gigabits per second. Newer versions of Gigi, which support 10 gigabits per second, are still not very popular. That's why Gigi is used mainly in applications which require small resolutions but longer cable length. The GMSL interface can support up to 15 meters of cable length, which is sufficient for most industrial use cases. Also, the connectors used for the GMSL interface are rugged and weatherproof, making them very reliable for industrial and automotive applications. While MIPI interface supports the highest bandwidth, it is intended to be used with cables of length lesser than 50 centimeter. Increasing the cable length higher than that can cause reliability issues in the data stream. With this information, I hope you have a good understanding about all the factors to consider while choosing the camera and interface for your application. I think it will be easier to understand the information from the previous slides when they are linked to a real life scenario. So we have some use cases to discuss as well. Let's take the example of the most popular robotic device in 21st century, the AMR, otherwise called as autonomous mobile robots. You might wonder how different this is from the previous generation of mobile robots called as AGV or automated guided vehicles. They both seem to be the same on the outside, but there is a vast difference in their functionality. For example, an AGV is capable of moving from point A to point B in a warehouse, but with certain restrictions. It requires a predefined pathway and it cannot move around obstacles in case there are any in its path. However, the AMRs are smarter and can easily move around obstacles. They also do not require much supervision as they are capable of mapping their surroundings and deciding on the path to take to reach its destination. Their capabilities can be compared to Tesla's full self-driving mode. But how does this all work? Magic? No. All it requires are multiple cameras and a lot of intelligent computing power on the edge. For example, 3D cameras are used in an AMR for understanding its immediate surroundings and for obstacle avoidance. The 3D cameras can be based out of stereo vision or time of flight technology. They both are capable of capturing the surroundings in 3 dimensions. This helps an AMR to recognize obstacles in its path and move around them autonomously. Also, monocular cameras are used to detect visual cues or markers in the scene, such as April tags, Aruco markers, or QR codes, to identify a specific location or to perform a specific task when a marker is detected. Some collaborative robots can even run neural networks on the edge, such as an object detection network to perform human detection so that the robot does not hit a person when they are in close proximity. Cameras are required to enable all this functionality. Hence, choosing the right camera for an AMR can be critical. If you are thinking about a camera for performing obstacle avoidance, select a 3D camera which is based on stereo vision or time of flight technology. Stereo vision cameras use two monochrome global shutter cameras in sync with each other, while TOF cameras use an IR based laser light source. They both can produce good results while used in a close range and under controlled lighting environment. The other purpose of cameras in AMRs are for object detection such as people and specific markers. The majority of AMRs today are slow moving devices and does not exceed a speed of 1 meters per second. For such cases, a rolling shutter camera with a fast readout rate can avoid both motion blur as well as a rolling shutter artifact. But in the case of faster robots, a global shutter camera must be used to capture images without any distortion that arises due to rolling shutter. This is something that happened with one of our existing customers who had difficulty in choosing between rolling shutter and global shutter cameras for a new requirement. We helped them by simulating their environment in our lab with a target moving at 1 meters per second under varying lighting conditions. We captured images of the target using different cameras and made sure there was no visible distortion in the images. We also ensured that the objects in the images could be recognized by the customer's AI model during this testing phase. Finally, the customer decided on the C3CAM CU55, which is a rolling shutter camera of 5 megapixel resolution with low noise characteristics. As technology evolves, it in turn makes our lives easier. Automated traffic monitoring is an example where cameras are used to automate a lot of functions in a traffic intersection. Cameras, along with an edge computer such as the Jetson Nano, can be used to collect data about the vehicles and pedestrians for intelligent video analytics. Some of the insights from this collected data can help find which location is the cause of congestion. Also, the time at which traffic is highest at any location can be analyzed using this data. Even pedestrian traffic can be regulated to reduce overcrowding in a particular area. This allows for efficient traffic flow. Law enforcement agencies can also use the vehicle data to issue warnings or penalties to traffic violators. Since this is an outdoor environment, the biggest challenge that arises here is highly contrasting lighting conditions such as bright and dark areas in the same scene. For capturing details vividly in this scenario, we recommend the usage of a HDR camera. HDR cameras combine multiple images with varying exposures to capture details in both dark and bright areas into a single image. High resolution is also required when more details about the scene, such as license plate information, needs to be recorded. When trying to perform automated number plate recognition or to identify traffic violators seated inside a vehicle, it is best to opt for a global shutter camera. This is because details are well preserved without artifacts even for fast moving vehicles. One of the other challenges in automated traffic monitoring is the flicker created by LEDs. This can be avoided when using a sensor which supports LED flicker mitigation technology, otherwise called as LFM. Some of our cameras, such as the C3cam CU81 and the Nilecam 21, are good options for traffic monitoring because of their HDR capability. We also have a HDR-enabled smart camera with its own AI processing engine called the SmartyCam. It houses a TX2 inside a rugged enclosure to run advanced video analytics on the edge. Using the SmartyCam and NVIDIA's powerful DeepStream SDK, it is possible to perform AI-based tasks such as vehicle counting and crowd counting on the edge. The metadata alone can be streamed over the network to a cloud service such as AWS or Microsoft Azure. When it comes to agriculture, robots have come a long way in making our lives easier. For example, robots are used for harvesting ripe fruits and other produce from trees autonomously using cameras and AI. Also, vegetation index is used to monitor plant growth and to make sure the plants are healthy and free of any disease. A camera for such use cases requires near infrared imaging capabilities. Image sensors with high level of quantum efficiency in the 700 to 950 nanometer of the light spectrum, such as the Starwish series from Sony, are good candidates for this. A monochrome camera can also be used because the lack of a Bayer filter allows for more light to fall on the sensor, improving its spectral response. We have multiple options of Sony sensors such as the IMX327 based Ecam21CU-NX or the IMX415 based Ecam80CU-NX. The Ecam50CU-NX has both color and monochrome variants, which can also be used for this use case. Another scenario in agriculture is a smart irrigation robot. The robot can move along rows of crop, ensuring water is supplied only to plants and not on the gaps between them. This ensures efficient water utilization for the crop. Such type of robots usually have a lengthy arm with multiple nozzles to spray water onto many plants in one go. In this case, object detection AI models are used to identify the plants in real time. Because of the length of the arm and due to the proximity with water, a GMSL based camera with an IP67 rated enclosure is well suited for this use case. Our SturdyCam 20 cameras are used in smart tractors to serve this specific purpose. The Xavier NX or the AGX Xavier are the platforms recommended for this use case because of their multi-camera support and ability to run multiple AI models with good performance. Road safety of vehicles is given a lot of importance in the automotive industry, and vision technology plays a key role in making our lives safer here. For example, there are cameras integrated into a car's dashboard which monitor the driver's alertness and driving behavior. The cameras and an edge AI processor provides immediate feedback in case the system detects that the driver is feeling drowsy or under the influence of alcohol and other substances. This is possible by using cameras and IR lighting to track the driver's eyes. Did you know that large goods vehicles, otherwise called heavy goods vehicles, contribute to over 63% of the fatalities in London? This is why the direct vision standard has been in effect across London since February 2021. This safety standard will apply to more regions in the coming months. The direct vision standard, otherwise called as DVS, measures the driver's view through the windows of a LGV cab. The level of visibility is denoted by a star rating system as per DVS. While truck manufacturers design new LGVs which comply to a higher star rating, it is possible to retrofit existing LGVs with cameras to improve their DVS rating. Again, the Steadicam cameras from Econ have an automotive grade sensor with HDR and LFM technologies, making them a good fit for this use case. Also, because of the IP67 rating of the cameras, they can work in all weather conditions, providing unparalleled visibility. One of the new age applications which has been gaining a lot of popularity since the COVID pandemic are drones, otherwise called as unmanned aerial vehicles. They have been used by hobbyists and filmmakers in the past to capture scenic views of landscapes. However, their ability to surveil a large location that is not easily accessible by humans make them useful for a lot of use cases such as for creating land surveys and mapping, inspection of tall structures, search and rescue missions, and even for last mile delivery of goods and small items. Cameras used for drones require a combination of high resolution and the ability to pan, tilt, and zoom. This allows the drone to see tiny objects even from a long distance or height. Also, thermal cameras are used for inspection of pipelines to find out if there are any leaks in the system. Some drones are even able to fly themselves with precision using multiple surround view or stereo vision cameras which allow them to create a depth map of their surroundings. Using this depth map and AI based obstacle detection, the autonomous drones fly even in an unknown and GPS denied environment. We will see more drones with autonomous capabilities in the coming years because of the evolution of edge AI computers such as the NVIDIA processors. They are power efficient and yet capable of running AI on battery powered devices. A common problem faced by drone manufacturers is that the camera cables are not rugged enough to handle the vibrations when the UAV is in motion. Also, it is important to take into consideration the flexibility of the cables so that they can be routed through an onboard gimbal for image stabilization of the camera. Our cameras for the NVIDIA series of processors come with a shielded coaxial cable which can be safely operated without any interference from the other electronic components in the drone. Also, it is more rugged than the standard FPC cables used for connecting cameras to small electronic devices. Thank you for being with us so far. I hope all that information was useful and helps you understand the types of products that you can also build using cameras and the NVIDIA Jetson. Over to Sesha now, who will explain about how Econ can help a customer's product development journey.
So, how can Econ accelerate your product development time? We call our go-to-market strategy as STEP: samples, testing, evaluation, and production. Our customers choose a suitable camera for evaluation from our pool of 64 off-the-shelf offerings. We offer consultation in helping our customers choose the right camera for their application and extend technical support as well in order to help them with the evaluation process. Our customers can either purchase directly from our web store or through Silicon Highway for UK and Europe deliveries. The customer then evaluates the camera and tests the image quality, software compatibility, hardware and mechanical compatibility, and express their feedback along with their expectations. Once the sensor is finalized, Econ ensures to stay with the customers in every step of the way while their product evolves from a concept to reality. From defining their customization request, if any, with regards to form factor, software related changes, or ISP fine tuning, till integrating the camera in their product. This is made possible through our well structured product management team. We have dedicated product managers for industrial, medical, and retail sectors, and they, with their expertise and experience in sector as well as with our products, guide our customers and travel with them until they launch their product in the marketplace. Our support not just ends there. Being a product development company ourselves and having been instrumental in deploying more than 300 plus customer products that are currently in the market, we understand the many challenges our customers may face on field. It is for this reason our team of product managers and FAEs also provide post-production support for smooth continuity of their products year on year. Now, let's talk about our camera portfolio. Some of the USB cameras from our portfolio are displayed here, and they range from 1.3 megapixel to 16 megapixel. The same sensors are available on MIPI and GMSL interfaces as well to meet the varying needs of different customers. We have a range of cameras to support various NVIDIA platforms like Jetson, Xavier NX, AGX Xavier, Nano, and TX2. Here are some of the products that support Jetson Xavier NX and Nano development kit as well as for Evermedia career board. We have developed synchronized multi-camera systems for NVIDIA processors, and here are some of the multi-camera systems for Jetson AGX Xavier and TX2 processors. Every requirement is unique, so if you have one that requires the distance between the processor and the camera that ranges from 1 meter to 15 meters, we have our specialized GMSL cameras on the store. These GMSL cameras are interfaced to Jetson AGX Xavier development kit and ConnectX, RudyNX or Rogue career board as well. So, are you envisioning a vision product? Write to us at sales@econsystems.com. Ready to purchase samples? Visit siliconhighwaydirect.com. Have any questions related to purchase? Write to sales@siliconhighway.com. Now we will proceed with the Q&A session. We have received some of the queries during the registration and we have answered most of them during this webinar. You can also enter your queries through the chat window available. So I will take one by one and our SME Dilip will answer these questions. The first question we have here is, what kind of cameras does Econ Systems provide for indoor head counting in retail stores?
So for indoor retail applications which require head counting, you would require a stereo camera with the depth sensing capabilities so that you'll be able to easily identify the head and separate it from the person's shoulders. So for this kind of application, you can connect the stereo camera from our portfolio with the NVIDIA Jetson series of processors. And some of our customers have already been using it for people counting applications in shopping malls as well. And we also provide the depth sensing capabilities using algorithms that run on the Jetson GPU, and it can be ported for different other platforms as well.
Thanks, Dilip. We'll move on to the next question. What camera is best used in a self-driving car and also most autonomous mobile robot?
Since this is an outdoor use case, it would be good to have the HDR feature in the camera, and because for a self-driving car, you would require a IP67 rated enclosure also, because the camera has to be mounted outside the vehicle, and we have the SturdyCam 20 series of cameras which can be integrated to the AGX Xavier, and the AGX Xavier is capable of running multiple AI algorithms parallelly. So this would be required for a self-driving vehicle to run algorithms such as perception and depth sensing. Yeah. Oh, sorry.
Okay, so we'll move on to the next question. Yeah. So the next question is regarding, does Econ provide custom Linux drivers?
All right. So the drivers required for the camera depends upon the interface that is used for the camera. For example, we have different cameras based on USB, MIPI, and GMSL. For USB, the default drivers are available within Linux OS itself. So if your platform that you're using has Linux running on it, so it will be directly compatible and you can just plug the camera into it and it will work out of the box. So if you are using a MIPI camera, we can develop the drivers, and we do support most of the commonly available platforms in the market, such as the Jetson series and NXP, the Raspberry Pi, even from the Xilinx as well. So the cameras can also be ported for different other platforms as well.
Perfect. So let's move on to the next question. How do you choose the camera for different computer applications? What is the possibility of Econ for to provide different camera applications cameras?
All right. So computer vision is a large area, and as explained above, uh, we have different cameras for different use cases. For example, if it is an outdoors surveillance scenario, so we recommend the usage of a HDR camera. And if you require for ALPR such kind of applications, you would require a camera which supports global shutter or maybe a fast readout time. And it depends upon a lot of factors actually. So depending upon the computer vision application, a specific requirement, we can support the cameras as well.
Perfect. So we'll move on to the next question. What is the maximum bandwidth with 4-lane MIPI CSI2 interface? 2-lane theoretically supports 5 Gbps. Then we can use a 4-lane camera for 2 lanes. So the ideal question is, what is the maximum bandwidth that is supported with 4-lane MIPI CSI2 interface?
So when it comes to MIPI CSI2 interface, not all the MIPI CSI2 interface provide the same kind of bandwidth. It depends on the processor as well. Let's assume we are going to use AGX Xavier. Then it is right. It can support a 5 Gbps over 2-lane MIPI interface. And obviously we can support a 4K at 30 frames per second for sure. But when it comes to different platforms, let's assume you're going with an NXP platform or a Qualcomm platform, it is not the same. It depends on what kind of DeFi it uses. The bandwidth different. Let's assume you're going to use IMX6 platform. Definitely, it is not going to support 5 Gbps or 2-lane. So it varies, depends on the platform.
All right. So moving on to the next question. Can you suggest a camera for AGV application with a vehicle moving at a speed up to 4 meters per second?
So a couple of things here, depends on what you're going to read. In most cases for AGV applications, it is going to either read a barcode or it is going to read some kind of marker to maneuver along the warehouses or in the industry segment. So we'll have to choose, definitely global shutter would be the right choice. Higher the frame rate, better the capability is, because 4 meters per second is quite fast. So you have to choose high frame rate global shutter cameras. At the same time, we will have to play around with some camera parameters to avoid motion blur. Regardless of kind of sensor we are going to use, still the motion blur is going to be there because of the speed. So we will have to play around with some of the configuration of the sensor to get the best out of it. So global shutter, high frame rate, low exposure, those are the combination we will have to try.
All right. Moving on to the next question. So the question is regarding how to configure the camera on Jetson and what are the possibilities to reduce the latency.
The configuration of the cameras is done in the drivers for the cameras itself. So for example, if it is a MIPI or a GMSL camera, we provide the drivers for the camera and all the sensor settings for the ISP, whether the camera can support internal ISP of the Jetson, or it could be a hardware ISP also. So for these different cases, we have separate drivers for them, and the complete configuration of the cameras is done in the drivers itself. Also for latency reduction, there are a lot of factors involved here. So when it comes to latency, for the Jetson series, even the MIPI drivers can support latency reduction mode. There is a separate control for reducing the latency. So this can be used in the software for controlling that. And also the latency of the entire setup depends on other factors as well, such as what is the resolution used and what is the frame rate of the camera used. So depending upon the exposure time also, the latency can vary. And if you're using compression algorithms to stream the data over a network, then also the latency can increase in that scenario.
Okay. Moving on to the next question. How does LFM work, as in light flicker mitigation work?
So if you look at our portfolio, we have a couple of cameras that support LED flicker mitigation. It is ideal for any outdoor autonomous robot or any ADAS application which works outdoor. It requires LED flicker mitigation to read the signboards. Also, anything like a traffic signal, it wants to read the traffic LED and understand what is the current status. It requires LED flicker mitigation. These LED flicker mitigation is one of the feature of onsemi sensors we are using. One is AR0233. That's a sensor specifically designed for automotive purpose, and it has a high dynamic range. And also there is a mode in the sensor that provides us LED flicker mitigation. If we enable that mode, we will be able to get LED flicker mitigation.
Right. So next question is, what is the difference between WDR and HDR? Based on my experience, WDR is better as it is in hardware based. Am I correct? So the question is, ideally, what is the difference between wide dynamic range and high dynamic range?
In quite often confusing terms, we use somewhere we use WDR, somewhere we use HDR, but generally during early days, since mobile phones, HDR is a technology used, and most of those HDR runs on the software. But anything runs on the software has issues, especially the HDR algorithms runs on the software would not be ideal, because you may have to sacrifice on the frame rate. If you are running the algorithm, HDR algorithm on the software, you will have to sacrifice the frame rate. But if it happens on the sensor, there are wide range of sensors available with the WDR support, and also it requires an ISP support as well. In the combination, if it happens on the hardware sensor ISP combination, if it works, that would be ideal. And as I said, both are almost same. Functionally, WDR, HDR is almost same. In many cases, they use it in both ways.
Okay. Moving on to the next question. Is it possible to use USB 2.0 camera for 10 meters?
It depends. Both USB 2.0 and 3.0. If you look at the specification, the specification says it supports for 1 meter, but we can obviously go for longer cable length. In case if you're okay to use repeaters, we can even go for 10 meters. Obviously, in both cases, 2.0 and 3.0. But without using repeaters, if you want to use single passive cables, then 5 meters would be ideal. There are quite a few vendors provide high quality USB 2.0, 3.0 cables up to 5 meters. So in case if you're going to use longer cable, 5 meters would be ideal. That doesn't comes with a repeater, uses the same cable for the power and the data. So anything beyond 5 meters, I don't think it's a good idea to go with the USB interface.
Okay, moving on to the next question. How to choose the right camera for agricultural purposes?
All right. Agriculture, there are variety of applications in agriculture as well. So as explained previously, so some of the applications would be for detecting weed or bugs in the field, like detecting the plants to specifically address or water them. So for these kind of applications, uh, HDR camera would be ideal because uh, since this is an outdoor scenario, the lighting, the sunlight would be directly, sometimes would be falling directly on the camera sensor, and this would affect the ability for the algorithm to detect the actual object in the scene, which is the plant or the weed or bugs.
All right. So moving on to the next question. Actually, this question has been repeated quite about 3 to 4 times. So, is there a pair of camera 2K or 4K camera at 90 FPS, 90 frame rate, that is providing for the use case of stereoscopy?
So we do have cameras with both 2K, which is full HD, and Ultra HD resolution, which can support 90 frames per second. And in case of full HD, even we can support 120 frames per second. And we do support synchronization. So by synchronizing two sensors, two cameras, you can achieve stereoscopy. Now the problem comes when you run the algorithm. If you are going to use a block matching algorithm for stereoscopy, 4K 90 frames per second from two sensors, it is going to be really hard. Even if it is AG Xavier, the SGBM algorithm for 4K 90 frames per second from two cameras is going to be tough. So choose the frame rate based on the processor or based on the algorithm. But we do have cameras with 2K, 4K resolution and also 90 frames per second with synchronization support.
Okay, moving on to the next question. What are the various G-muscle cameras available?
All right. So we have different cameras for GMSL from 2 megapixel and even up to 8 megapixel resolution. So some of these cameras also support the IP67 rated enclosure as well. So this can be used for outdoor purposes. And these cameras support HDR with light, LED flicker mitigation technology as well, as previously asked in another question. And depending upon the use case, we can recommend these cameras for you. Also, these DMSL cameras are directly compatible with the NVIDIA AGX Xavier and also the Rudy NX kit from the Connectec. And one of the advantages of the GMSL cameras is that it can support a longer length cable, even up to 15 meters. So depending upon your application, we can even customize the cable length to suit your needs. Also, these GMSL cameras are not just, I mean, they are directly plug-in, they can be directly configured on the Jetson systems, but we can also support other platforms as well. So as long as your platform that you're planning to use supports a MIPI interface, we can integrate the cameras and the GMSL serializer, deserializer into your system.
Okay. Done.
Yeah.
Okay. So another question: what are the certifications available with our off-the-shelf cameras? So all our cameras are FCC compliant, and it comes with both ROHS and REACH certification. And all our cameras comes with 3 years warranty for the mass manufacturing of cameras.
Okay, so we do have a lot of questions. Unfortunately, time doesn't permit to answer all the questions here. So we will end with this last question. After this question, we'll be sending you all the question and answer bundle over email to everyone. So the last question for today is, what's recommended camera for UAV?
It depends on the purpose we are going to solve. If it is if you are looking for an aerial view camera to capture several things and recognize objects, probably higher resolution. Any higher resolution camera would be ideal because all the objects are going to be really small at a longer distance. So we would recommend either 4K or 13 megapixel camera from our portfolio because that comes with a digital zoom option. Some of our customers are already using it in drones uh, for aerial view applications.
Thank you. So we will end the Q&A session with this. You can avail 10% discount on sample purchases from Econ Systems web store, which is available until 1st of October. I would like to take this opportunity to thank you all on behalf of Econ Systems and Silicon Highway for your time today. We sincerely hope that this webinar was worth your while. We look forward to working with you all in the near future and extend the best of our services. Have a great rest of the day. Thank you.